Hey everyone, Jeremy here. Welcome back to the Towards Data Science podcast. Today's episode is about one of the biggest outstanding open questions in AI, period. And that is the question of whether we'll be able to get to superhuman levels of intelligence using current AI systems. One of the reasons that a lot of people are skeptical about whether we'll be able to achieve superhuman intelligence using conventional machine learning is that conventional machine learning algorithms are typically trained on data that was created by human beings. So the logic goes, how can you ever achieve superhuman intelligence by training it on human level data? Now, there are a lot of strategies that speak to exactly that question, trying to get superhuman intelligence from human level data, one of which is called iterated distillation and amplification, or IDA for short. And while IDA itself comes in a lot of shapes and sizes, one of the most common and fruitful applications of IDA to date has been question answering systems. Now, that typically involves breaking down complex questions that in theory could be so complex that they're not human understandable into simpler questions that humans can actually parse and that AI systems that are at human level can actually answer and work with. And my guest today, Ethan Perez, is an expert on IDA flavored question and answer systems of exactly that type. We're going to be talking about those systems, about his thoughts on how they might give rise to AGI, and his thinking more generally about AI safety. So lots to get into. I hope you enjoyed this conversation as much as I did, and without any further ado, here we go. Hi, Ethan. Thanks so much for joining me for the podcast.
Hey, good to chat.
I'm really happy that you're here. This is actually a conversation that I've been excited to have at some point with someone, and you're just absolutely the best person to have it with. I'm really curious about your views on a particular kind of alignment, AI safety, AI alignment strategy, a family of strategies that broadly falls under debate or IDA, and we'll get to what that is in a minute. But first, I want to get to understand you a little bit and explore sort of your background, how you came to this space in the first place. So how did you discover AI safety and AI alignment, and what brought you to do research on it full time?
I was generally excited about the long-term impacts of AI. I sort of early on had some background in math, and I was thinking about, oh, what is sort of the impactful things I can do with that kind of background, and got more into machine learning. And then I read Nick Bostrom's book Super Intelligence, which I think is probably a common read for people with these interests. And I think it just generally got me thinking a lot about the long-term impacts of AI, that I should really be thinking about like what happens when we get technology that is close to human level or even surpasses human level in its abilities. And that might be the kind of thing that happens at the end of my lifetime or not even in my lifetime, but it's really, I think, where a lot of the impact of AI will have, and where we'll be able to use AI to actually advance our human knowledge, which is the thing that I really care about.
By the way, sorry, just to ask a little bit about the superintelligence side of things, like what was it about superintelligence that shifted your view on things, or how did your views shift as a result of reading the book?
I think it's that the book focuses a lot on very long-term considerations. I don't think I had the expertise at the time to sort of gauge the very specific arguments that Nick made about existential risk and other things at the time. But I think it did make some arguments that AI and like very powerful AI systems were plausible. One key argument that I remember was like, let's say that we had a system that could achieve human level ability on some tasks, and like maybe some imaginable way to do that is to just emulate the human brain. And that might be just extremely computationally expensive, but at least in principle, it does seem possible because we are sort of an example of such an intelligent system, and we just need to sort of like copy that. And then if you do some sort of copying procedure, maybe if you don't think neuroscientific route is plausible, we could do this with like supervised learning or unsupervised learning on human text or data at a very large scale and get something to a similar effect. But that seems sort of plausible. And then he makes this point that, oh, well, you could just speed up or parallelize that software at a very large scale and then get something that is superhuman in one sense, and that it can do things much more quickly than a human could, but at the sort of like human level quality of ability. And I think that got me excited about like, oh, there's just like so many things that I'm bottlenecked in terms of like my reading speed, in terms of like how much I can learn. And it would be like really exciting if I could just have 1,000 copies of me like go read different parts of the internet on, I'm like looking up a new diet or looking up a new philosophy question and then like sort of like report back to me all the information that they gathered. And I think that that was kind of a plausibility argument that seemed pretty realistic to me of like, oh, it seems pretty reasonable that we might get systems that can do much more than we can intelligence wise.
Yeah, in a sense, it's almost like it plays with the idea that intelligence is a very like poorly defined thing where, you can be super intelligent even by just replicating human neural hardware almost exactly, do it in a different medium where computations are just faster because it's substrate of silicon rather than cells or something, and you immediately have something that is, for all intents and purposes, superhuman, even though the algorithms are just human. It's kind of an interesting, the hardware
Yeah,
software side. So did that prompt you, like you read super intelligence and you were like, I know I want to make this my life's work?
that motivated me to take my first like major research internship.
At Mila,
And
right?
yeah, Amila, yep. With Aaron Corville there, who was like just a really great mentor and had like other really good peers there, and ended up having a successful paper out of there. And then I like really enjoyed the whole process. I'm really excited about just how we can help humans advance our collective knowledge using machine learning. Like I just like read a lot and I'm always excited to like learn more about the world. And it kind of sometimes I feel like very bottlenecked. Or I feel like, oh, we really need like step changes in our ability to answer some questions about the world. Like especially I think about this in regards to like philosophy, where it seems like, oh, these are like just really hard questions where it seems like it would just take us like many more years in order to answer some questions there. And like we really need to be thinking about new ways to approach really challenging questions. So then I think after the first research internship, I started to think more broadly about like, oh, what are the kinds of methods that could actually let us get beyond human ability? Yeah, I mean, there's sort of like not really many ways to do that that seem plausible. And that's where I came across iterated distillation amplification as well as debate are in those contexts of like different paradigms to get past human ability and not just like imitate human ability, which supervised and unsupervised methods are able to do.
That actually brings us to another interesting aspect of this, which is, so right out the gate, you're approaching IDA, iterated distillation and amplification, this thing that I've been teasing since the beginning of the conversation. You've talked about that as a way of achieving like superhuman capabilities from AI systems. So I'd love to discuss that, because usually when I hear IDA talked about, I spend more of my time talking to people in the AI safety community. So they're focused on IDA as a way to achieve safe AI systems that can be interrogated. And I want to talk about that too. But I'm really curious about what is it that prevents us from getting superhuman performance without IDA? I think that might be an interesting place
Yeah.
to start.
Yeah. I mean, I think the baseline, like the starting point to think about it is, well, the default way that we would train systems to answer questions is with supervised learning. So this is like all the state of the art and like sort of standard methods for training systems to answer questions in NLP are just using supervised learning, where we like collect a large data set of answers to questions, and then we learn a mapping from questions to answers. Like that's a good paradigm as long as we can collect the answers to questions, which is possible for a lot of the sorts of questions that like people are Googling around for, and like very factual questions like when was this person born? But that paradigm basically just breaks down when we aren't able to collect the answers to questions. And then basically then we just don't have any training data to train our supervised learning algorithms. And so that's basically the problem that iterated distillation and amplification is trying to solve, is that let's say you have a system that can do human level question answering because you've trained it on data where we have answers to questions collected by people. So you have this like sort of black box, like good question answering system. Now the problem is, well, how can we use this system to answer some question that's like out of its distribution because it's not been labeled by the answer to a question? So let's say like questions in philosophy, I think would be a good example because we just don't have labeled answers to those kinds of questions. And so they would be out of distribution and might require some sort of different reasoning process to get to the answer. But we have this really good question answering system that can answer a lot of sort of other related questions. And so the way we can think about approaching this problem is by breaking this out of distribution or hard or question that we don't have the actual answer to breaking it down into sub-questions that we can answer with our existing question answering system. So we can break it down into, I don't know, if the question's like, do people have free will? We can first have like a question about what does it mean to have free will? And then we can have some questions around the neuroscience of free will, et cetera, et cetera. And then for each of those questions, we can answer them with our question answering system, or if they need to be broken down further because they're challenging, we can break them down further and then answer those sub questions. The hope is that by continually breaking these questions down into sub questions, we'll eventually bottom out in questions that a supervised question answering system could train, and where those sub questions are the kinds of questions that we would reliably expect our trained model to like accurately answer. And then like now we've answered like a bunch of different pieces of this larger problem, and it should be much easier for us to predict the final answer given the answers to these sub questions.
And so the idea to nutshell, to make sure I understand it, is you have like some complex or really difficult question, and that question would nominally require like a superhuman intelligence to answer it. You have a maybe human or slightly even subhuman level intelligence that you've trained. You've been able to train it because you have a whole bunch of questions and the answers that real humans have given. So you're able to use those two things to train this like roughly human level intelligence. And then the hope is that we can break down this really complex question into sub questions that eventually can be answered by this like slightly less than human or roughly human level intelligence. That's the plan?
Yeah, exactly.
So does that, that's so cool, because to me it seems like if that were true, if it actually is the case that we can do this, it seems to imply that in principle there is no question, and correct me if I'm wrong about this, but there's no question that cannot be broken down into sub questions that are ultimately human understandable.
I think you might get into, if you make the very general statement, you might get into issues around like Gödel's incompleteness theorem, where like we know that there are some true statements that we can't prove the answers to. But like maybe there's like modest versions of it where like some of those examples that are used to prove Gödel's incompleteness theorem are a bit odd and like not really like, people don't really like generally care about them. But like you might say that like for most questions that we like really care about, there might be some reasonable way to like break them down into sub questions, like sufficiently many sub questions. It might be like just an extremely large number of sub questions in some cases that we would be able to answer them. Yeah.
Sorry, can you elaborate on the Gödel's incompleteness theorem in connection to this? I think there might be some listeners who aren't familiar with Gödel's incompleteness theorem, and it's an interesting aspect of this.
Yeah, I mean, I'm definitely not an expert on it, but
sure, yeah.
As I understand, the like simple statement of the claim is that like there exist true statements which we know are true, but cannot construct a proof to show that that true statement is true. So these are often like self-referential statements, which are like
a set that contains itself or something like that. Yeah.
Yeah, or like this statement is false, or like they have that sort of quality about being self-referential. That kind of initially made me sad. I was like, oh well, like we can't just prove every true statement. Like that's really disappointing. But I think it would be even a big step. I mean, those are weird because they're self-referential, and like there's sort of an existence proof that we can't provably like reason to every true statement. But I think it's sort of unclear to me the extent to which like that actually holds in practice.
And I guess that itself is its own interesting question, like speaking to the limitations of IDA or the limitations of any strategy. I mean, to the extent that from a safety perspective, we want to use something like IDA to make a super intelligence that could explore arbitrarily complex ideas. If those ideas end up involving areas of logic that are like not ultimately human tractable, in the sense that we actually can't break them down into even human understandable terms, then it's sort of like the genie's out of the bottle. We've essentially no hope of regaining control over that thought process and predicting the behavior of that system, right?
Yeah, I guess so. I mean, I guess you might want a system that can say like, hey, I can't answer this question, or
right.
like this, I like no proof found given computational resources I have, something like that.
We talk about IDA by referencing like a human level system or an almost human level system, and then we talk about how that can lead to superintelligence. So I guess one question I'd have is like, what is IDA like today? Like, what is the state of play, and what can you do with IDA systems that maybe you can't do otherwise?
Oh yeah, I think that's a great question. I mean, like I think that these kinds of systems are useful now, because fundamentally they're. I mean, this is like the amplification in iterated amplification, where you're amplifying the ability of an existing system that you've trained to be able to do slightly more. So yeah, so in some of my work, for example, I've taken standard question answering systems which can answer like questions about a single paragraph in Wikipedia, and those are like very good at answering a question about a single paragraph in Wikipedia, but they like struggle to answer questions, or like it's not clear how to apply them to questions where the answer is like in multiple different Wikipedia articles or different paragraphs. So like one example of a question would be like, who was born earlier, George Washington or Abraham Lincoln? That information is in just two articles in Wikipedia. And what I've done in my work is train a model to first generate sub-questions for that original question. And so you'll get some sub-questions to the effect of like, when was George Washington born and when was Abraham Lincoln born? And then you can just answer each of those individually with your pre-trained model, and then pass both of the answers to the sub-questions to another question answering system along with the sub-questions. And then it should be able to predict the answer by basically like taking, I guess, an argmin over the two like answers to sub-questions, basically. It makes the whole process much easier, and then we show that it like improves the results on a like, yeah, a current like popular benchmark for question answering.
And how do you train it to identify sub questions? Like how I'm struggling to think of is it just like a labeled training set? Is that what you use?
Yeah, so I think that would be the simplest thing, but there's sort of like a weird kind of supervision. Like they're not that common to get these sort of like question sub question pairs. Yeah, like another simple strategy, if you don't have that much supervision, I have a paper coming out which does this, which is to basically like leverage these kind of like large language models that can adapt from a few number of examples to generalize to doing this. So yeah, so we've basically been using GPT-3 plus some other tricks to generate sub questions. You sort of like condition on a question sub question pair or few sub questions, and then you prompt with a new question, and it can do pretty good sub question generation. And then there's also like in another paper that I had, we were basically just trying to see if we could generate these sub questions completely without supervision. And there we kind of use some of these like crazy methods coming out from unsupervised machine translation to do that. But yeah, I can go into more detail on that if you're interested. But there's sort of like, that's kind of a high level of the different kinds of methods you could use.
Yeah, no, I find it really interesting that you're looking at effectively augmenting GPT-3 with, I don't know if the terminology would be like a little bit of logic, or like a kind of logical structure that you're baking in. I mean, this kind of brings me to another question, especially as somebody who's working in this space with a lot of Q&A type problems. Like, how impressed were you with GPT-3 when it came out? How surprised were you as well with how well it could perform?
I've been pretty impressed. I think maybe the places I've been most impressed are specifically for like using the model to generate arguments or generate advice or like other forms of like long text generation. It's just like really good, especially on the kinds of questions that most people ask, because there's just probably the most amount of training data on that. So anything related to like politics or like political controversies or economic controversies, apologetics, and sort of like religious debates. It actually like just does a reasonable job at like I don't know, quoting Bible verses or like other like very like crazy things, because probably there's just a lot of discussion about those kinds of things on the internet. And so it's just way better than any model I've seen at doing those sorts of things. Yeah, I think the places maybe where it fails are like if you want something that's very precise, like if the correct number of outputs is like 1, and like there's not really any other correct outputs that you would want. Like if you're wanting an answer to a question, like you need the exact answer to a question. It still is. I mean, it's not really using supervision. I think that's basically where like supervision is helpful, is to like get the exact sort of thing that you want for your task.
Do you think it has a plausible model of the world behind it? Like, to what extent? Because I think one of the areas people have been debating a lot is like, is GPT-3 basically like a glorified memorization tool, where it's like,
Yeah,
like you said, oh, I've seen this before. I've seen somebody have this particular argument about a Bible verse before. I know what to quote. Versus it's actually sort of connecting dots at a higher level of abstraction. Where do you see it falling on that spectrum?
yeah, that's a good question. It is definitely doing some generalization. Like, yeah, like a friend and I were playing around with it recently where he was kind of skeptical, and I was like, oh, well, what would convince you that it's doing some sort of generalization? And he was like, well, it's probably seen a lot of like recipes on the internet, and it's also probably seen writing about unicorns, but it's probably never seen those two together because I don't know, like that just seems unlikely. So he just like sort of prompted it with having a like give me a recipe for how to make like unicorn eye soup. And then it just like sort of goes off into talking about how we need like rubies, and we need to like smelt the iron ore and like put it into the soup and like sprinkle it with some gold dust on the top as like a garnish, and
Wow.
like it was like very detailed. And yeah, I don't know, that sort of seems like a prima facie like evidence that it is doing some sort of generalization. And I think to some extent, it seems kind of hard to catch cases where that just doesn't really do a good job. Like,
Do you expect on that basis that as GPT-3 is scaled, I mean, obviously Google's just come out with their like 1 trillion parameter model, and we can expect more scaling to come in the near future. Like, do you think scaling is likely to bring GPT-3 to the point where the IDA strategies that you've been at least exploring most recently are kind of subsumed by it, where like it's good enough on its own to not require that kind of augmentation, or where that augmentation can then be used to like target the next layer of failure for that model? Is this, in other words, is like scaling GPT-3 plus IDA, can that get us arbitrarily far, I guess is what I'm trying to ask.
yeah, I think the nice thing about IDA is that it just leverages whatever ability that you have to get a model that can do more. So I think I'm not concerned about like larger language models subsuming the need to do IDA, because whatever like large language model you have, you can always make it answer more kinds of questions by running this sort of question decomposition process. So far, it does seem easier to get that sort of benefit from question decomposition the better our models are, because yeah, like you can just generate better sub questions if you have a better language model. Like question decompositions from GPT-3 do better than question decompositions from our previous like sequence to sequence methods, even than like pre-trained ones, which also do better than like methods that don't use sequence to sequence learning. There's just like a clear gradient where like the benefit from the sub questions improves. Yeah, so I think there's like an increase, we'll see like an increasing large effect from doing this sort of question decomposition.
That's interesting, because I would have guessed like that at a certain point, as these language models get more and more sophisticated and they build out like a more and more complex model of the world, that model of the world would include the value of question decomposition, and therefore that essentially like the GPT-N, let's say, could optimize both for question decomposition and for answering the questions at the same time. In other words, you'd kind of benefit from that interaction, where if it's all happening under the hood of the same
Yeah,
optimization engine.
I think that seems correct. As long as you have training data for the amount of decomposition that you need to do. Like
Mm.
if I don't know, you like GPT-3 might be trained on some questions where it needs like a couple or like yeah, 2 to 4 sub questions maybe. And so it might just be doing this internal decomposition process and predicting the answer. And who knows, you might be able to even decode like the sub questions from the internal weights. But I think the tricky bit is like how do you get generalization to
Right.
questions that require even more decomposition than just the ones that people are generally answering on the internet. And I think that's where this structured process is helpful, because you can just arbitrarily decompose the questions into sub questions. Yeah.
So it's this, what I love about this is it plays with like this, I have this mental model of like physics, or maybe you call it physics and logic, and like machine learning as two ends of a continuum. So, you know, in physics, what we do is like we go out into the world, we run a bunch of experiments, and we try to identify like underlying rules that seem to apply all the time. Like no matter what, these rules are always true. The speed of light in any, you know, in any frame of reference is always the same. The gravity works the same way, and so on and so forth. And like the laws of logic are sort of similar to that, where, you know, it seems like you're assuming a law of logic here, the law of question decomposition, that you can coherently decompose complex propositions into simple propositions, and that will always be true. And so it's almost like you're taking the sort of trial and error machine learning, kind of like, let me feel my way around the elephant, but never actually, like, machine learning models don't actually come up with rules. They come up with like predictive models, which are a little bit different and a little bit less fundamental in flavor. It almost feels like you're coupling the two together. You're saying, okay, you're really, really good at building this model of the world. It's a very flexible model, but it fails the moment it encounters something that it hasn't been trained on. So let's augment it with this principle that we think will be true independent of context to give it much greater reach. Is that like a fair kind of framing or description of?
Yeah. No, I think that was mostly it. Yeah, you nailed it.
Do you think that do you think there's anything that IDA plus GPT-3, or GPT-N, I should say, will not be able to do? Does IDA get us across the superintelligence AGI finish line? Or is there other stuff like, I don't know, self-play or reinforcement learning that will have to be coupled to these systems?
Yeah, I think that's a good question. At least if you are wanting to answer questions and not say like take actions in the world, then I think a like language model plus question decomposition will get you quite far. Some of my uncertainties are around like one issue that I've sort of found is that there are just cascading errors where like if you answer a sub question incorrectly, then
Mm,
that can propagate as an error into the final answer. So if you answer like when was George Washington born as like 1900, then you're going to answer the
right.
question like was he born earlier than Abraham Lincoln incorrectly. And so I think there will need to be like a lot of thought about like how we do the question decomposition process, like how we use the answers to sub questions. We might just need to like do lots of different question decompositions for any different question. Like we might also want to just directly ask the question, like maybe there's just some text in Wikipedia that says George Washington was born earlier than Abraham Lincoln. And so we might just want to ask the question directly. Maybe the birth dates are not available, and so we want to look at like when they died. And maybe if the differences between when they died is like large enough, then we could get some estimate that would like let us do some Bayesian update on like when their birth dates were. We might want to sort of like ensemble a bunch of these different results of
Right.
question decomposition, and also like other things that are important, I think, are like looking at the confidence that the model that's answering the sub questions has at predicting the answer. So like one thing that I've found is that when that model is less confident of its answer, it's likely that the entire process will end up with an incorrect answer, which I think makes
That
sense.
makes
But
sense.
it's
Yeah.
sort of like the kind of thing that like we should actually like carefully tune. It sort of emerged in the system that we built, but like it's the sort of thing that we should be careful about. Where like, oh, like maybe we should actually train models that are better calibrated and like see how we should use their confidence to affect our confidence in the overall prediction. There's like a lot of different parts of the system that I think do need to be carefully looked at in order to get the whole process to work out properly.
Yeah,
Yeah,
and definitely is high stakes, especially I guess as far as those earlier questions, I presume are concerned, right? Like the sooner the system makes a mistake, like the sooner the entire tree gets compromised that comes after. Is that
yeah.
okay? This actually brings us to, because you mentioned ensembling. So, you have a whole bunch of different question decompositions. Question decomposition one leads to one conclusion. Question decomposition two leads to a different conclusion, and so on and so forth. And eventually you average out, or you let them all vote, and you use that to ensemble their predictions, and you get something that's more robust. What about the other angle of this, which is getting these systems to perhaps undergo some kind of debate process? I know that's another thing that you've been working on.
Yeah.
Can you speak to like debate and its importance in this context?
Yeah, I think the high level idea is similar, which is that when we have a question that is more difficult or complex, or some like out of distribution somehow, we need to break it down recursively somehow in order to get to a point where we can actually make an assessment from a model that's trained with supervised learning. The way that debate approaches it is in a different way, where the way that I'll motivate it is by starting out about like how you might approach this problem from a reinforcement learning perspective. So like let's say you're trying to ask a model, should I eat keto? Like give me an answer with some explanation of like why I should think that you're giving me some good answer. If you don't have that kind of supervision for those explanations, one possible thing you might want to do is just have your language model generate an explanation, and then you just check the explanation, and then you see like, oh, does this seem reasonable? If it seems reasonable, then an RL type approach would just like reward the language model for giving a good explanation and answer, and like negatively reward if it doesn't seem correct. So I think this kind of thing makes a lot of sense if you think that the answer is easy to check, but hard to come up with. So like math proofs might be an example where like, oh, there's like a really complicated reasoning process in order to generate the whole proof. But like once we have the proof, then it's much easier to just check the answer, and then we can reward the model for positively for coming up with a proof. So that like reinforcement learning type approach will plausibly get us past human ability, because the like we aren't actually generating the answers. We're having the model come up with, do some expensive computation to come up with the answers, and then we're checking them. But the failing is that it's like unsafe, or like could be misaligned with our values, in that we're basically just optimizing a model for generating convincing answers, or answers that look correct.
Things that
But
things
that
that we will consider to be convincing. Yeah.
yeah, yeah, exactly. And so I think that's where the motivation for debate comes in, is that, well, we have one model answer a question, and then we can have the same model sort of bring us considerations about the answer to this question that we might miss, and that are like very convincing cases about against this answer. So maybe it provides another answer. And so now we have like both the original answer as well as like a counter answer, and like these for like a like for a good model might be like two of the best answers to this question. And like there we might think that, okay, like now we're like more informed about like maybe some missing information that we might have not had. With debate, in a similar way as like iterated implication, you can just iterate the whole process. So then you can just say like, okay, given I have this like answer and like rebuttal answer, I can like generate a counter argument to that response answer, and a counter argument, et cetera, until basically we have enough information for a human to predict with like reasonably high confidence what the correct answer is. And then we can use that to like, since we have like reliable human judgments on this sort of like data, then we can train reliable models to make the same prediction just using supervised learning.
And so the hope here would be that you get two AI systems to debate each other, and in the process, they end up revealing the strengths and weaknesses of each other's arguments in a human intelligible fashion, so that we can go, oh, like this AI is malicious and it's trying to fool me into I don't know, helping it along in its plan for world domination, whereas this AI is doing the right thing, is its answer actually makes sense when I see the debate play out. Does that actually work? Like, I guess one thing I'd imagine, or one issue I'd imagine here, is like, as these two systems that are debating vastly exceed human ability to kind of to follow their reasoning, you end up in a situation where there's a decoupling between, like you said, what sounds convincing to humans and what actual logic would dictate. And as the logic gets really complicated, it seems like it would become much, much easier to deceive a human and much harder to convey the real the real true arguments.
Yeah, I think that is basically a key uncertainty with this approach. Like you might think that as the models that are running these sort of debates get better, then both the arguments and the counter arguments get better in a way that is helpful, like in that you're more likely to catch errors in an argument. But yeah, it does seem like there are some interesting experiments, like human experiments that OpenAI has run where they have just smart people who know about physics like play this process of debate and just try to have like sort of a lay like non-physicsy, not too physicsy person try
Yeah.
to judge the debate, and it just seems like really, really difficult for me to assess some of those debates. So I think it's kind of another thing where I think the process needs to be like tweaked in order to figure out how we can get the most easy to judge debates in a way that we can still feel confident that we're getting a good, reliable judge of the whole process.
Yeah, because it almost seems like, I don't know, naively to me, it feels like there's a cursive dimensionality aspect to this, where the more complicated the problem domain becomes, the more sophisticated the reasoning becomes, the more high dimensional it is, the like the more spare degrees of freedom these AIs have. And it seems like those degrees of freedom, like that's the space that you need to kind of wedge in deception. And it seems like that space just grows as the problem increases in complexity. um, but yeah, hopefully there's some underlying principles that we can actually uncover that would let it scale a little bit more.
It seems plausible that you might need some combination of these methods. I don't know, like train some IDA type system, and then because it's done this sort of like decomposition, and then it's like above human ability and what sorts of like questions it can answer, and also like what sorts of debates it can judge. And then you might want to use that system as the judge for this debate process. And so it might be able to do a better job than just like using a human annotator as a judge directly. With debate, I think one of the motivations is like this might be a good training signal. If you can train a model to accurately judge the results of the debate, then you can just use that as a reward signal for some sort of like self-play, even like AlphaZero type system where the models like optimize the reward and get better at generating these arguments. And then as they get better, like you might also think that they might be better judges for the whole system. There's like different combinations of these like puzzle pieces that we can try to fit together, but it's sort of like an open question about what's the best way to do it to get us reliable judgments.
Well, and one thing that I'm curious about too, like, and this informs both the strategies that researchers choose to work on, and also like their attitude towards safety and the kinds of alignment and AI safety techniques that they feel compelled to work on. So there's a tight coupling between those technical questions and like thoughts about AI timelines, like when you think an AGI, human level general intelligence, or something that we could refer to in those terms, is going to arise. Do you have like I don't know, do you have a take on that? And if so, has that informed your position on whether to work on capabilities or alignment or anything else?
Yeah, I made a prediction on this. There's a really nice thread. I might have to send it to you later, but there's a really nice post from this group, research group OT, where they like collect a lot of different people's AI timelines. And I think from that,
I'll post a link. I did see your illicit plot. So everybody
cool.
check out the blog post that'll come with the podcast, and you'll be able to see Ethan's illicit post, because I think it's kind of interesting.
Okay, great. Yeah. Yeah, I think it depends a lot on your definition of AGI. I think I was like considering that like it would both need like good language modeling abilities or like language abilities, good vision capabilities, and like be able to take actions in the world. And I think in my prediction, I sort of decouple it into two cases. There's one case where we get general intelligence from combining existing components that we have currently and scaling them up with the compute that we have. And then there's another component of my distribution, which is like in the case that that other scenario doesn't work out, well, it's sort of just this prior over the next like century or a couple centuries that like well, not really sure when it's going to happen. So I'll just have some like decaying distribution over the timeline. In that second scenario, it seems very uncertain when we'll get general intelligence because it could just be plausibly some like very hard breakthrough that like we've already been working on the problem for quite a long time, and so like it might just take a really long time to get the necessary like breakthrough that we need. But in the other scenario, it seems like quite plausible that in the near term, like if we get a larger like GPT style models, if we have enough compute to get like a good performance, then I think it seems possible that we get quite good language models, and then we just need to like combine them with a visual component, which is I think the direction that like Clip and DALL-E and some of these other models are going in. And then we just need to sort of like give them some ability to take actions in the worlds or be able to train that. Like
Some
we would
body.
want, yeah, maybe I don't know if I'm like tied to like physical embodiment, but at least the models should be able to, for example, like run a company, like
Mhm.
choose actions that are like optimizing some goal. And that seems like it might need a bit more work beyond just like getting an understanding of vision and language.
I think you've posed this problem in a way that everyone implicitly has posed it in their minds, but no one's ever made it explicit quite in the way that you did, or as far as I've seen in that comment. Um, the central question is like, hey, do we have we solved all the conceptual problems that we need to solve? Basically, do we already basically have all these ingredients, the reinforcement learning, the deep learning? We just smush them together and add a pinch of scale for flavor, and then we end up with an AGI? Or is there some like fundamental thing, whether it's some weird quantum effect or something we're gonna have to figure out to make AGI actually work? And if I recall, you actually said you thought there was about a 1 in 4 chance that we currently have everything we need to achieve liftoff. Is that correct?
Yeah, I think that's right. I mean, it depends a lot on your definition of AGI. Like,
Right.
I mean, I think language models alone that are very powerful are probably like quite good enough to
Quite
get
general.
like, yeah, quite like have massive impacts on the world. I said like 1 in 4 in that post, but I think probably like most people would be lower than me on that. Some people would be higher. Um,
Oh, interesting. So you think most people would think that there probably are some missing conceptual
yeah,
ingredients?
I think that might be sort of like an opinion that's getting worn down by some of OpenAI's scaling work. But like generally, it does seem to be the case that like most researchers are like, oh, we do need some like big like new ideas in the way that we're approaching things.
And when I looked at your plot, one of the things that struck me was you had it essentially the probability of us hitting AGI spiking sometime in the next 10 years or so is basically your big bump that's associated with the possibility that maybe we already have everything and all we need is scale. So within the next 10 years, we'll be able to scale our way there. And then of course you got this big period of like high uncertainty where you're like, I don't know, if it doesn't happen in that time, scaling doesn't work, then who knows when we'll have the big idea. Does that cause concern? Like, are you worried about that possibility that we might hit AGI like in the next 10 years? Do you think that we're prepared for it from a safety standpoint, from an alignment standpoint, from a philosophy standpoint?
Yeah, that's a good question. I think to some extent, it seems kind of hard to work on some of these safety methods without having, yeah, just like good
Capabilities?
models. Yeah,
Yeah.
like it is just hard to actually like generate a good sub question to a question like before we like it would have been really hard to do that like a couple years ago. Yeah, so like part of me feels like, oh, like these methods are going to become more useful um as we get to closer to very powerful language models. Yeah, but also like it does seem like I don't know, like maybe it feels like we need like a period, like a long period where we're like close to having strong language models and like have a lot of time to develop our methods, and then like oh, then we'll be ready for it, and we'll like have all these methods for like scaling past human ability in a way that like generalizes properly. So yeah, maybe it's like more the shape of the trajectory
Interesting. I
that
mean,
matters to me.
does that imply though that we would know? Because right now I think we're scaling the biggest machine learning model in the world. has been scaling by, I think, a factor about 10x every year. So to me, this seems to suggest that we're very likely to not kind of hum along just below human level intelligence while we sort out a solution, but like rather, shatter right through that threshold and create something way bigger than we can handle. Is that a plausible concern, or is that something that you think is obviated by something else?
Well, I think it will be pretty compute limited. If in the case that we get methods that are like generally intelligent from our current set of methods, it looks like the direction that that's going is like we require a lot of scaling. And so in that case, there's going to be some trade-off between like the quality of the model that you're getting and the amount of compute that you're using it for. So I think that sort of does limit the amount of, yeah, I guess the amount by which you can sort of like really increase quickly in terms of intelligence. Yeah, it seems like, I mean, we definitely need a few more orders of magnitude of compute to get even like near human level intelligence. At that point, it's like you're using a large budget, a large fraction of like Google's R&D budget in order to train the model. It's kind of a question of like, well, how much more money is there to spend on these? And like, it seems like a process that's going to like take a while, like to get at least like some amount of time to like, maybe it's even going to have to be like some sort of like governmental project to like gather more than Google R&D budget amounts of money to like scale the models. But it does seem hard to like just blast past. And like we also have these like very predictable like power law curves in terms of like how is the loss for language modeling going to go down as we increase with compute. And that is like the amount of gain that we're getting is slowing down in terms of how much better we're getting at language modeling from training with more compute. And so I think those factors all kind of suggest to me that things will like slow down a bit.
Well, and I guess if they do, that would suggest that strategies like IDA are probably going to be, all the more valuable as we look for that little extra nudge here or a little extra nudge there. Is IDA going to be necessary to get across the AGI threshold? Like, or are there plausibly other techniques that, like, is IDA on its own as a plausible way, in other words, of getting us to superhuman levels of performance from systems that are trained on human level data?
Yeah, okay. So like the characterization in my head is something like a very good language model will capture the full distribution of human intelligence and ability. It has the knowledge about what the very upper end of human intelligence is like. So like, for example, like I prompted GPT-3 as if it's like a conversation between two faculty at Stanford, and then the conversation is very distinct, and that's where they're like sort of citing different like famous people and like very high quality, like well-formed English and stuff like that.
A very sophisticated conversation.
Yeah, exactly. And there, I think like there it's clear. I mean, that seems like, I mean, it's above the mean of like human intelligence in terms of quality. So I think that's like, that seems like a reasonable place that like, I mean, maybe you might just consider that like superhuman already, if like, depending on what you consider.
Right. Right, is picking like the top 1 percentile of the human population. Is that a superhuman thing? I mean, maybe, yeah.
Yeah, I mean, that would already be quite useful. Then I think maybe if you use some sort of like reinforcement-based approach, like the one I was describing, you could get beyond that. But I think you would start to see some of the failings that I described, where models are generating answers that are convincing, but not necessarily correct. And there, I think you get into dangers about like, well, people are probably going to use the answers because they're like probably correct, but they're also like optimized to just like convince you, and therefore you might be taking important decisions based off of like incorrect information. So I think that is like the regime where like when we try to scale past that level of human ability, then we might want to like, or we might basically like need to use distillation and amplification or debate kind of methods to like get us past this regime of human ability in a way that like we are like confident will work.
And are you overall optimistic when it comes to, like, because we've talked about IDA's potential as a way of amplifying these systems, of getting superhuman level performance. It seems like we do have strategies that, at least in principle, seem like they have a decent shot of getting us to super intelligence. And whether one of those strategies works or something else works, it seems quite likely that we will eventually get there. Like, are you optimistic about our ability to control these systems, and well, maybe wielding them wisely is like a separate question, but just our ability to control them to make sure that that we don't let a genie out of the bottle that we'd rather put back into the bottle?
Yeah, I think that that's one thing that's nice about um, like question answering systems is that we sort of decide what we do with the information. It's not that we're having systems act autonomously on the own, which is on their own, which is I think is where a lot of the difficulties come in. I mean, there are still difficulties with doing this like question answering problem correctly, but I think there if we can like really nail this, I think like simpler problem of just getting models to generalize past human ability in just the domain of like prediction, like answering questions, then I think we can use some of those methods to help us in the more general case where we want our systems to just autonomously take actions in a way that's like not supervised by humans. And for example, like I think one way to like make that connection is to use this sort of like question answering system trained with IDA or debate to provide a reward for systems that are, I don't know, like running manufacturing, like Amazon manufacturing, or like
Mm-hmm.
making like CEO level decisions at a like tech company or something like that. I think if we have some sort of superhuman question answering system, that it might be much easier to get accurate evaluations of these systems that are taking very long-term actions.
Interesting. Okay, well, hopefully question answering systems are going to be a big part of the solution here. Really appreciate your time and your thoughts on this, Ethan. And do you have a personal website that you want to point people to, actually, so if they're interested in
Yeah,
following your work?
yeah, it's just ethanperez.net.
Awesome. .net. Awesome. I like it. Very what is it? I don't want to say hipsterish, but it's like it's got that nice aesthetic. Yeah. Great.
That's good. It was the only one available. I was
Nice,
looking.
nice. Welcome to 2021, I guess. Yeah. Well, Ethan,
Yeah.
thanks so much. I really appreciate it.
Yeah, thanks for having me.